Hello guys, welcome to continue our session. Here I'd like to remind you how to find the limit of rational function. Uh, Today I will give you more practice on case number 1, finding the limits of rational function by using dividing out technique. I will give you more practice on this case. As I told you before, we use this case when the function in numerator and denominator are polynomials function. This question number 1, 2, 3, we solved it already before. Okay. Today, I'll give you more practice how to find the limit of rational function. As you see here, that is a rational function. In this case, we use the dividing out technique, not rationalizing technique. That is a summarize of what you learned during this week. Okay, that is the first case. I will show you the 3 cases today, inshallah. More practice on dividing out technique, rationalizing technique, and simplifying the function by simplifying the function also. Here, in this case, I have to follow the 3 steps which I told you before. The first step, look here, substitute. If we get a number, go ahead. It will be what? The limit. If we get a number over 0, math error, it means or undefined value. In this case, the limit does not exist. If we get 0 over 0, as I told you before, undetermined value, in this case, I need to redefine the function, then substitute. I'll show you here. The first case, substitute. When x approaches to -1, I'd like to find the limit of the function x squared minus 1 over x plus 1 when x approaches to -1. By replacing by -1 in the given function, which will be -1 square minus, don't forget, when we replace by any negative value, you have to put it between 2 brackets, over -1 minus 1. Calculate the value of the numerator, which will be 0. The value of denominator here, plus, it will be 0. In this case, limit, as I told you many times, the limit exists. I need to redefine the function. In this case, I redefine the function in this case by dividing out technique, as I told you before. Since both numerator and denominator are polynomial. But in this case, I can make a long division and I can factorize the numerator and factorize the denominator if we need. But here it is a difference between 2 squares, x minus 1, x plus 1. I think all of you know how to factorize binomial, which represented what difference between 2 squares. Here x plus 1. Then cancel the common factor between the numerator and denominator that make the denominator equal what? 0. So it will be x minus 1. That is the redefining of this function. That is what? Redefine. The first one, substitute. The second step, what? Redefine the function. Okay. The third step, substitute again in the redefining function. In this case, I will write limit, okay, x squared minus 1 over x plus 1 when x approaches to -1. It will be like the limit the redefining function when x approaches. It means the limit of the given function, it will be the limit of the redefining function when x approaches to the same value as us. Replace again. Here, substitute in the first step. If we get 0 over 0, limit exists. Second step, redefine the function, because I know when we have undetermined value, in this case, limit exists, but we need to redefine the function. Then substitute in the redefining function, it will be -1 minus 1, it will be -2. I think it's so trivial. You can factorize this one. Most of you know how to factorize any binomial, trinomial, or any polynomial. The others one can use the calculator mode 5, 3 if we factorize quadratic binomial, okay? Here, for the next question, this one, let's solve this one. I can do or finding the result of this definition or dividing out by using dividing out technique. I can use the long division also, but I think in this case, if it is possible to factorize both numerator and denominator, it's easier for you. Okay, this one, step 1, step 2, step what? 3. Step 1, substitute by using negative 3 here. It will be between 2 negative 3 all square plus negative 3 minus 6. Okay, here 9, 3, okay. Here negative 3 square minus 9, it will be 0 over 0. Limit exists, I need to redefine the function. Factorize the numerator, which is so trivial. The denominator here, here I need to factorize both numerator and denominator. The first step, common factor. I don't have any common factor. So it is what? Trinomial. Here x, here x. Plus 3 minus 2. I know all of you know how to factorize. Binomial, difference between 2 square, x plus 3. Cancel the factor which make denominator or which repeated in numerator and denominator, which is here. What? This one together. So what is the redefining? I don't have any more factor to cancel x minus 2 over x minus 3. I think it's easy. The third step, replace in the redefining what function? X squared plus x minus 6 over x squared minus 9 when x approaches negative 3. It will be the same as limit x minus 2 over x minus 3 when x approaches negative 3. Okay, just replace, substitute in the first case and in the first step and the last step. Here it will be negative 3 minus 2 over negative 3 minus 3. It will be negative 5 over negative 6, which will be 5 over 6. That is the limit of the given function. I think it's so easy. By the same way, in question number 5, factorize numerator and denominator, cancel the common factor, then replace the in the redefining function. I think I remind you well about the dividing out what technique. Okay, let's remind you by another technique, which is talking about the others one. It should be homework here. Sorry, I'm sorry. Question number 6 and 7. It will be homework. Just apply the rule that we gave you. Okay, here the second case I use rationalizing technique if any one of numerator and denominator is not a polynomial. Is not what? A polynomial. Sorry. In this case, as I showed you before in this exercise 1, 2, 3, I showed you how to use the conjugate. It's so easy. I remind you by solving question number 4 and number 5. By the same way, in this case, please focus with me. The first step, second step, third step. You have to know first step, substitute in the function. Okay? From the first step, I identify, I will continue steps 2 and 3. Maybe I get number, it will be the limit. If we get number over 0, does not exist. Okay. If it is 0 over 0, in this case, I will continue the solution. Substitute, it will be what? Square root 4 plus 5 minus 3 over x minus 4. It will be here 3, it will be 0 over. In this case, if we get this result, when we substitute, I have to continue the solution. Step number 2, in this case, since the one of the numerator, here the function which in the numerator is not polynomial because we have a variable under the root. In this case, we use the conjugate. But I multiply the conjugate in numerator and denominator by the conjugate of the function which is not polynomial. Here, which is in the numerators, okay? It will be square root x plus 5 minus what? 3. X minus 4. I multiply both numerator and denominator by the conjugate, but here it must be like this one, okay, right between two brackets. Multiply by the conjugate here of numerator, which represented by x plus 5. Instead of minus, we write 3. Just write the expression as it is, but change the sign between the two terms by the opposite sign. Here, both numerator and denominator by the conjugate of the function which is not polynomial. Okay, here I'll multiply as I told you before. Okay, multiply, it means the difference between two squares, squaring the term which has square, it will be what? Under the square. Okay, minus, don't forget here minus, that is in the root. Okay, the squaring of the second 9. Okay, again, the square of any term of any root, it will cancel of any square root, the squaring cancel the root because they are inverse to each other. Here I keep the product of the other function as it is here. I don't need to multiply. Just multiply, find the product of any expression and its conjugate only. Here it will be x minus 4 over, simplify the numerator over, keep it as it is. Square root x plus 5 plus 3. It's so clear the numerator looks like the denominator cancel together. It will be what? What is the redefining function? Here it means 1. It will be 1 over square root x plus 5 plus 3. That is the redefining what? Function. In this case, the third case, I have to rub this one to show you. That is the second case to redefine the function. The last step here, please, for this problem, limit the given function, which is what? Square root x plus 5 minus 3 over x minus 4. When x approaches what? Negative 4, it will be at the limit of the redefining function square root x plus 5 minus, plus 3 when x approaches what? 4. Okay? When x approaches what? 4. Sorry, here 4, not 4, negative 4. I'm sorry, by mistake. Just replace, it will be 1 over 9, 1 over 6. Because here square root in denominator, numerator 1. Denominator square root 9, it will be 3 plus 3, it will be 6. That is the limit of this function. Clear or not clear? This one for the second step. I hope you understand. When we use the conjugate, if any one of the function in the numerator or in the denominator is not polynomial, how I know? If we find the variable under the root or in denominator, okay, or variable which has negative power like this one. In this case, if we have the variable under the root, I use the conjugate. Understand? Simplify to find the redefining function, then replace in it again. I hope you understand, okay? Question number 5, we can continue to solve number 5, and I leave you to solve the other question as homework, because it's enough. I summarize what I give you during this week. Sorry, we solved it 4? Yes. Solve number 5? Now, I hope you solve before I solve, then pause the video first, then open it to watch the video and know what is the correct answer. Here, what is the first step? As I told you, I think it is so easy. The first step and the first step and third step substitute. The first one I substitute in the given function. The third step I substitute in the redefining function. Number two, it will be the redefining function. Here it will be square root x plus 1 minus 2, x minus 3. Okay, sorry, I have to replace. I'm sorry, I replace here. It will be, sorry, I'm so sorry. Here 3, and here what 3? It will be what? 0 over 0 undetermined value. It means the limit exists. I need to redefine the function by using the conjugate because here the numerator is not a polynomial. Here I write the numerator, which is x plus 1 minus 2, here x minus 3, multiply both numerator and the denominator by the conjugate of the function which is not polynomial, which is here in numerator. In what? Numerator. Multiply both, but here please don't forget, write each in the function in numerator and denominator between two brackets. Here, what is the conjugate of this one? It will be the same, x plus 1, replace minus into plus, what, 2. Over square root x plus 1 plus 2. When we multiply any expression by its conjugate, it will be that, as you see here, that is as the expansion of what? Difference between two squares. Okay, what is the squaring of the first one? It will be the squaring of the first one, which will be square, cancel what? The root, square root. It will be x plus minus, don't forget, every time this one it will be minus, squaring the second, which will be what? 4, x minus 3, multiply, don't multiply the two expressions which they are not conjugate to each other. Plus 2, okay, here it will be, what is the product? Simplify the numerator, which will be x minus 3. The other one, I keep it as it is, x minus 3, multiply x plus 1 plus 2. In this case, cancel. It will be 1 over square root x plus 1 plus 2. The third step, as I told you before, limit the given function, which is here, square root x plus 1 minus 2 over x minus 3 when x approaches what? 3. It will be like the limit of the redefining function x plus 1 plus 2 when x approaches what? 3. Just replace, it will be here, sorry, 2 square root 4 to 1 over 4. I hope you understand well. That is a practice to remind you how to find the limit of rational function. The first technique, I give you 2 examples on it, or I give you 2 exercises on it to find the limit by using dividing out technique. Here again, I give you what the 2 exercises on how to find the limit of rational function using rationalizing technique. Look here, the last step here, the other one, it will be homework. I solved it already with you, question 8 and 9 in previous video. Now I'd like to solve number 10 to remind you. Miss, every time, please, the first step be the same, okay? The first step and third step. Here, the first step, substitute in the given function. It will be what? Half replace, just replace in numerator and replace in the minus half over 0. It will be 0 over 0 undetermined, undetermined value. So I need to redefine the function. In this case, by simplifying, as you know, any fraction we can write is as what? As division. That's right, operation. Here it means the numerator, which is what? 1 over all x plus 2 or 2 plus x, sorry. Okay. Minus half. That is the numerator, divide the denominator. I have to follow the procedure or the steps of dividing rational function. Okay. As we do with rational number also. Here 2, I'm sorry. I multiply, use the cross, multiply here by 2 and here by, don't forget, here the denominator, 2 plus x, and here what? 2 plus x. I think it's so trivial now. Then find express the numerator or the dividend here, this value, the first one. It will be 2 multiply 2 plus x, and I don't need to multiply, okay? Keep it as a product. Then what is the new numerator? 2. That, understand, that is the new denominator for both. I have to make this 2 fraction like fraction. Express both of them by another equivalent fraction such that they are like fraction. Okay, here minus, but here I distribute, don't forget, negative 2, negative x. Clear? Okay. Here, as you know, I simplify, I here divide x. I'll do step by step. This one cancel because they are opposite to each other. It will be negative x over 2 multiply 2 plus x. Keep the numerator as it is, or the dividend, multiply the reciprocal, 1 over x. Then simplify, as I showed you before, negative 1 here 1. So what is the value of this redefining function? Negative 1 over 2 multiply 2 plus x. I don't need to multiply it, but if you multiply, no problem. That is the redefining function. I have to simplify, okay? Follow the order of operation. I have to do the operation which in between two brackets here. That is the numerator. This one, it should be divide, yeah, numerator divide denominator. I have to do the operation in numerator first. Okay, in the numerator first. Be careful in this step. Divide the denominator. Okay, I have to simplify the numerator first, the operation in numerator, then divide the denominator. Follow the procedures of adding, multiplying rational function or rational expression. Okay, here then the last step here, which is limit the given function. I will name it f of x. This is all f of x. F of x, when x approaches 0, it will be what? The limit of its redefining, which is what? Negative 1 over 2 multiply 3 plus x. When x approaches what? 0, it will be, if you replace, it will be negative 1 over 6, I think. Yeah, replace, yes, that's right. I hope you understand, okay? Because it's so trivial. I swear, if you follow the procedure, okay, you will find it so easy. Now the last thing I'd like to show you here. You have to remember this rule, but later I will prove this one for you. Sine, as you know, trigonometric is, or transcendental function sine ax. Here, that is my angle. Here, a is the coefficient of the variable x in the angle. That is my angle. Sine ax, that is the angle, over bx, it will be the coefficient of the angle. It means the number which multiply by x when x here over b. But don't forget, x should be approaches what? 0. Otherwise, no. That is my rule. Limit sine ax over bx when x approaches 0, it will be the variable here over the, the coefficient of the angle over the coefficient of denominator. By the same way, limit tan ax over bx when x approaches 0, only 0, okay? coefficient here and the coefficient here. How to apply this one? Here it will be so trivial, mental. Here the coefficient 1. What is the coefficient? It means the number which you multiply by x in the angle over the number which you multiply by x in the denominator. Okay, it will be 1 over 5. By the same way here, what is the number multiplied? That is my angle. The number here over the number here, it will be 2. Okay, here x approaches what? 0. It will be 3 over 1. I hope you understand. Thank you for joining the session and have a nice day. Thank you. Bye-bye.